Welcome back to our beginner tutorial series. In today's video, we are diving into a super important concept: control structures, specifically the conditional statements and loops. These allow your R code to make decisions. They give your code the ability to control the flow of execution based on specific conditions, or to repeat actions. Let's start with the most basic, the if statement. The syntax is pretty straightforward. The condition inside the parentheses must evaluate to either true or false. If it's true, the code inside the curly braces gets executed. If it's false, that code is skipped. Let's see an example. Let's say we have a variable temperature equals 15. Notice how nothing prints when temperature is 15. That's because the condition temperature greater than 20 becomes false. Often, we want to do one thing if a condition is true, and something else if it's false. That's where if-else comes in. Here is the structure. If the condition is true, this code will be executed. Otherwise, this code will be executed. Let's modify our temperature example and run the if-else conditional statement. See how R now decides which message to print based on the temperature. This is fundamental to creating flexible programs. What if you have multiple conditions to check? That's where else if shines. You can chain as many else if statements as you need. Here is the structure. Let's build a more complex weather message. Notice how R goes through the conditions in order. As soon as it finds a true condition, it executes that block and skips the rest of the else if and else blocks. For loops are incredibly useful when you need to repeat a set of actions a specific number of times, or for each item in a collection. Imagine you have a list of tasks, and you need to perform the same operation on each one. Instead of writing the same code over and over, a for loop automates this repetition for you. It iterates through a sequence like numbers, elements in a vector, or names in a list, and executes a block of code for each item. The basic syntax for a for loop in R is as shown on screen. The variable will take on the value of each element in the sequence during each iteration. Let's start with a simple numeric sequence. We can use the colon operator to create a sequence of numbers. Here, I takes on the values 1, then 2, then 3, and so on, up to 5. And in each iteration, we simply print I. We can also use sequence function to create sequences. This will print 10, 12, 14, 16, 18, 20. Loops are particularly powerful when working with vectors. Let's create a vector of fruits. Notice how fruit takes on each value from the fruits vector, and we use paste to combine strings. You can also iterate over numeric vectors. This is where it gets interesting. You can combine for loops with if statements to perform conditional actions within your loop. Let's find all even numbers in a sequence. See how we are checking each number, I inside the loop. This is a very common and powerful pattern in programming. While loops are fantastic when you need to repeat a block of code as long as a certain condition remains true. Think of a while loop like this. Keep doing this action while this condition is true. Unlike for loops, where you know the exact number of iterations or the elements you'll iterate through, while loops are used when the number of repetitions is unknown beforehand. It depends entirely on whether a condition evaluates to true or false. The syntax for a while loop is: crucially, you must ensure that the condition eventually becomes false inside the loop, otherwise, you'll end up with an infinite loop. Let's look at an example. We want to count up to 5. Here, count starts at 1. The loop continues as long as count is less than or equal to 5. Inside the loop, we print count, and then we increment count by 1. This increment is vital. It's how count eventually becomes 6, making the condition false and stopping the loop. A somewhat less common, but still important loop in R. The repeat loop. While for loops run for a defined sequence and while loops run as long as a condition is true, the repeat loop runs indefinitely until you explicitly tell it to stop. A repeat loop is an unconditional loop. It will execute its block of code over and over again without any built-in stopping condition. This means it always needs a break statement inside to prevent it from running forever. Think of it as: repeat this action, and I'll tell you when to stop. The syntax is the simplest of all loops. Let's build a simple counter that stops at 5, similar to our while loop example. You can see it counts from 1 to 5, just like our while loop. The key difference is that the stopping logic, the if count greater than 5 break, is placed inside the loop's body. Without that break, this loop would run forever. The break and next statements allow you to fine-tune exactly when your loops stop or skip iterations. Break. The break statement immediately terminates the loop it is currently in. Execution continues with the statement immediately following the loop. It's like an emergency exit. Next, the next statement skips the rest of the current iteration of the loop and moves to the beginning of the next iteration. It's like saying, skip this one and go to the next. The break statement in detail. Example with for loop. Stop searching once a condition is met. Imagine you have a list of numbers, and you want to stop processing once you find a number greater than 5. Notice how processing number 9 and processing number 2, etc., are never printed after 7 is found. The loop stops as soon as break is encountered. Example with while loop. Here, break acts as our stopping condition, even though the while condition itself is true, which is why break is essential in repeat loops. The next statement in detail. Now, let's look at next. It's used when you want to skip only the current iteration and move to the next one, without stopping the entire loop. Example with for loop, skip odd numbers. You'll see only the even numbers printed. When I is odd, next is executed, and the print statement for that odd number is skipped. Example with while loop. When count is 3, skipping 3 is printed, but processing count 3 is not, because next sends the control back to the top of the loop for the next iteration. This concludes our episode on R control structures. If you found this helpful, like and subscribe to stay updated with the full course.